Hello everyone, welcome to Embedded Systems course with Arduino. In today's session, we are going to cover liquid crystal displays interfacing to Arduino. So liquid crystal displays, you would have heard of LCD TV screens and all of that, right? So the functioning is remains the same, right? So what happens? These LCDs have liquid crystals inside them, okay? And once you apply a voltage, right, to this liquid crystals, right, they disintegrate, okay, and once they disintegrate, they allow the light to pass through it, and that is what lights the LCD TV screen and allows you to display the characters, okay. So now we are interested today in a certain type of LCD, right, which is 16 cross 2 LCD, right. This is very easily accessible, easy to interface, and therefore widely used in embedded systems, displaying text and creating, right, wherever you have to display text, right. So why 16? So you can actually have two rows in this LCD, right? This is row 0, this is row 1, and you can display 16 characters, or you can have 16 columns, which means that this, right, per row you can display 16 characters. So in total it comes down to 32 characters, right? So this is one character, right? A box, if you just zoom in, you will see this is one box. So this is one character. Now this one character, right? So this one char is made up of 5 cross 8 pixels, okay. So if you zoom in again, you will see that small boxes, okay. So I will, if this is one character, right, and you have 5 columns, right, then you will have 8 rows, okay. So this side it will be 8, and this side it will be 5. So this is 1 pixel, okay. So this one is 1 pixel, okay. So similarly you have 40. So the default CAD size is 40 pixels, right, and you will have 16 on each row, so total 32 groups of 40 pixels, okay. And this is what makes up your this LCD, right. So if you zoom in, you are seeing, right, you will see small boxes also. So these are 5 cross 8, that is called CAD size also, okay. So now let's see what are the pins which are available on this LCD, right. Even if you take this physical LCD, which you can easily get online or from market, you will see the same pin configurations. Now here, so you can give 0 volt, right, the VSS, this is 5 volts. Now this is used to set the contrast, right, contrast you would have heard of. So what you do, we connect a potentiometer, we connect a potentiometer to this. What is potentiometer? Potentiometer is variable resistance, right? You vary the resistance and you can change the contrast, right? So you would have heard this of, right? So if you change this, you can vary the contrast, right? Now this LCD, let's also understand one thing. This LCD has two things, right? So you also have to send the instruction and you have to send the data, whether you have to read, whether you have to write what was written, right? So you need to understand that LCD is in what state, right? You can either switch off the LCD, switch on the LCD and all that, right? So it has a command register and it has a data register, right? So to select whether you are sending a command or a data register, you use this pin, okay. Now read or write. So default 0 is write and 1 is read. Mostly we are going to write, so we connect this to 0 volts, right, and that is how it is. Now enable, to enable the LCD, we'll use this. Now this is your data pins. Our LCD in general, works in two modes, okay. So one is your 4 pin mode. So 4 pin, we are going to use 4 data pins, or we can use 8 data pins, right? Now 8 data pins, what happens? The data will be sent faster, right? Here to send the 1 byte of information, you have to send 2 nibbles. So this configuration is a bit, you can say, slower. Okay, and this configuration is faster. Today we are going to configure the LCD in a 4-pin mode. Okay, we are going to use this. Okay, so this is the basic use of these data pins, right? And now of course, to control the backlight, you can configure this cathode and anode to resistance and ground, and this is how you can control the backlight of it. So these are the basic pins on a 16 cross 2 LCD. Let's move ahead, right? So I wanted to display this pin mapping of from Arduino to LCD, right? Because there are more number of pin connections, and you may miss or you may forget what pin to connect to which pin of Arduino, right? So what we said, we are going to configure today in a 4-pin mode. So we use 4 data pins: D4, D5, D6, and D7, and we use right. If you see here, we have taken this, right, 4 data pins here, and we will drive this, configure this as an output and drive accordingly, right? Now, but from the starting, we have connected this to 0 as we discussed. This is 5 volt, and this is a potentiometer. You vary this, and you can change the contrast. You can change from here, right? The VE pin. Resistor select to whether you are sending a command resistor or a data resistor, whichever you are selecting. So for this RS pin is there, right? Read and write 0. So right, so it's what it means, we are writing, right? Enable will be driven from the Arduino, right? We said that we are going to configure in a 4-pin mode. So we have taken 4 D4, D5, D6, and D7, right? And we connected to 2, 3, 4, and 5, right? Now LED and LED plus pins we have connected. This is used for backlight, right? This is used for your backlight, right? So these we have connected, one to the variable resistance and another to a ground. So your backlight will be driven by these 2 pins, right? So we should only remember that we have to configure 4 data pins, and we have to configure the resistor select and the enable, right? So only 6 pins we have to configure. Rest we can connect it to the power supply which we have given to the breadboard, right? So this is the thing to remember, and we'll, once we start connecting in Tinkercad, we'll again revisit this circuit, okay, just for our understanding, and we'll then start designing the circuit, right? Now we have designed the circuit, right? So we know that the Arduino is a C++ based environment, right? C++ based code. So what we have done is, we are including this library now, this LCD library, which is compatible to most LCDs present worldwide, right? So this library has all the inbuilt functions which can help us to create our code in a much efficient and convenient manner, right? Okay, in the sense, we don't have to provide hex codes as commands, and then again we have to provide certain hex codes to write and all, right? So instead of removing those hex codes, what we have done, we are using certain libraries. Okay, so this is the library which we include in our code, right, by default whenever we are driving LCD, right? Now what we do is, we create an LCD object, right? So we create an LCD object. Okay, now this LCD object, right, will ultimately use the functions which are present in the libraries. So this is created using this liquid crystal function, right? So all these, right, what I said is that instead of writing, so these are ultimately hex codes only, right? These all commands go as hex codes only. Okay, now begin is what? So begin initializes the LCD. This initializes your LCD, right? And what you have to give, you have to give column. So column is what? Column is 16, you know, rows is 2, and we told that this is default and this is optional, but the default is 5 cross 8. You can have 5 cross 10 also, right? The one character consisting of 5 cross 8 pixels, total 40 pixels, right? So this is optional. This parameter is optional. Okay, you don't need to give this. Okay, now LCD clear, this will clear your screen. Once you have written anything, you can call lcd.clear and clear it. Okay, now set cursor, right? So let's revisit how was our LCD, right? So this was our LCD, right? It had 2 rows, right? And it had 16 columns, right? Something 16 like this, right? Now this was our 0th row, this was our 1st row, and this is our 0th column, 1, 2, and so on, right? So now if we have to set cursor to this position, right? like let's suppose this. So here you can give 0th column, 0th row, right? But if this is what, so this is 1 and this is 0. So this is, you will set this 1 comma 0, right? So similarly, this is used to set the cursor at a particular position you want to start writing from. Write data, provide the string in this function, and that data will be pushed to the LCD, right? Similarly, print function also does the same, but you have a flexibility. Like suppose you want to write any number in hex or in octa or in decimal, right, or in binary, you can provide the base. This you can provide this parameter, but this is also optional, right? Scroll display left, right? You would have seen that the data, right, you can like if you write just say hello, right? Now if you want to keep shifting the data one character towards the left, right? So this is what you're doing, you're scrolling, right, towards the left, right? Now you want to scroll towards the right, so you will have scroll right also, right? So you have both the options, scroll display left, scroll display right, and auto scroll means it will keep on auto scrolling. You also have no auto control, no auto scroll, that will stop this, okay? So this is auto scroll. So these are the very common functions which are used across LCDs, right? And we are going to use all of this when we design our circuit and code it, right? We are going to include the library in the top, create a LCD object, right, and use all these functions post that. Okay, so this is how your basic LCD works, right? And the important thing is that we remember what pins we connect, right, to the LCD. That is important to us, and we will see that in the next session. Thank you for joining.